Hi everyone, thanks for coming today. This webinar is going to be sort of a continuation of the one that I did last month. I'm going to talk about that as well. So this is going to be more how BDD looks like in action, with Action Jackson, of course. How it looks like in terms of the code, the development cycles, the feedback. We're going to talk about all these things and how they fit together. And it's going to be more down level than what we did last time. And we talk about that as well. So let's start. So I'm Gil. Hi, testing Gil. I'm a trainer and consultant on all things that are related to quality. That includes on the developer side, unit testing and clean code and things we're going to cover today. Developer tests and on the QA side, all kinds of things about testing and automation, a wee bit of DevOps and product, everything that contributes to quality products, which I think that's a worthy goal. A part of what I do is not just talk, also advise people on how to do BDD properly and what properly really is. A whole discussion, and we can discuss that if you actually want to. So if you're interested in either spelling correctly or anything that I mentioned, and look at the side, there are other things as well. So there's a whole slew of workshops that I offer, and whatever you need, we can probably make sure that you get it in a custom fashion. So let me know if you're interested and need something, including what we're going to talk about today. So if you haven't watched the last webinar, it was like a high-level view of what behavior-driven development is and what we think it is, which is kind of set of tools, which is not, and what kind of problems it was supposed to kind of fix and what it actually did and how people really implement it today. So this was more of a high-level introductory thing to BDD. And we didn't get into, actually, I showed a couple of examples, but I didn't show like the process. And this is what we're going to do today. I am going to show examples today with Cucumber in JavaScript. BDD tools are everywhere, so that means you can write specs, of course, but any language that you use probably has some kind of BDD framework, and we'll talk about in a minute of how Cucumber works. So it's everywhere out there, and most of them kind of work the same, which I'm going to explain. We are going to build something today, sort of, in a sort of a real imaginary way, and I'm going to show you what it is. We're going to talk about something that I haven't mentioned last time, which is how tests fit in. And we're going to talk about AI and how that fit in, because kind of changes things a bit. So I'm going to talk about my experience working with tools today in order to incorporate that into my process and like a teaser for something that is going to come in the future very soon. So the architecture is basically something like that. We have a product on the right-hand side because that's where products are. And we have a way to operate it. So if you think about it, like Cucumber is sort of like a test framework. Sometimes it is, which is going to be the case today. Sometimes it's a library that a test runner runs. So it depends on the implementation and what kind of language you use. But the input for that are these guys here, feature files, which are really text files and written in a sort of an English way. It's called Gherkin because Cucumber. And Cucumber really is the translator or the mapper between the English language that is written here to the bits of code we call either step definition, Cucumber or glue code, depending on what we're using, which kind of things to operate, the pieces of code that operate the product. So what happens is this is like something that the developers write, and this is what the business writes. And these things, if developers wrote them, would be like tests, automated tests. But BDD had other lofty goals where the business would actually write the specs. The non-technical people would do that, and the glue would be written by developers to operate the product. The product could be anything from APIs to UI or something like that, or bits of code. It could be, you can use Cucumber for unit testing as well. It could be like very 10 kilos hammer to fire to hit like a very minute problem, but it can be done. And I think I showed it last time. So that's the architecture. Basically, you have to like run the full product, complete environment, whatever environment you decide to run, and it will just do that. So I don't have a real calculator here, but I have a calculator. And this is what we're going to build today. We're going to build like APIs. Basically for the calculator, it's a server-based thing, and we have a reset API, and we have a press key, which sends a key, and get the display, which gets what to display. Now, there are a couple of assumptions that I'm going with here because I'm both the product manager and the developer and the tester, which allows me great flexibility in deciding things. So the first thing that I decided is that the APIs are already defined. And this may or may not be the case in your implementation of what we're going to do this. So what does it mean? Sometimes, like classical BDD, means that you specify things in the feature files and you kind of describe what you want the system to do, but you don't specify how the APIs are. Now, assuming that your product doesn't have public APIs, just private APIs, it doesn't matter how they look like. The developers can define them any way they want to. And as long as they do what they need to do, it's okay. It's not true if the APIs are public APIs. They're going to be documented and specified, and clients are going to rely on them, not changing. So it depends on what your situation is and what your product is. I decided to go with APIs that I'm not going to touch, like stay the same for the entire next 45 minutes or so, but things can change after that as well. The other thing that I decided to do is starting from scratch, which happens not a lot in software because usually you don't start from scratch. You already have some things. This doesn't change much as things progress. You'll see in my examples of things that are going to change when requirements change. And what do you do then? So I'm going to give examples of that as well. So that means that we're going to jump into the code with Marty. So my example today, like I said, it's going to be in JavaScript. And for my simplicity, it's going to be both the product is in JavaScript and the client is in JavaScript. So I'm using Cucumber JS in order to run this. I want to mention that it doesn't have to be. This is just like for me to make it possible, but your server could be JavaScript and your client, your specs can run in Java or Python or whatever, so it doesn't have to be, but it's more simple to show them inside one instance of VS Code. Another thing I chose to use for the product Nest.js, because I'm building APIs and I wanted to learn something that I didn't do before, so I did that. You see that examples kind of have some kind of cheating in there because I'm not going to type everything because I prepared everything in advance. Just so you know, the server is running locally, and what you see here, we just do this again. So as you see that I don't have anything up my sleeves. All the Cucumber specs are running, not failing, if you're patient enough. Well, every dot here is a test or a spec inside it. So let's start. One hint for you, when you see ignore here, that means that if I run it, it will fail. That's basically it. But I was smart enough to put ignore, so when everything runs, it will not fail. So this is step 0, really. This is the calculator display operations. The background is that PM told me that the calculator is server-based, so it needs a way to reset it. Once reset, we can press keys and ask for display to see what to present. And since I'm not to be trusted, I'm going to start with very simple cases, the zeros. So the scenario is after reset display is 0. So given I reset the calculator, the display should be 0. And the other one is pressing a number, the display changes to show that value. Given when I reset the calculator and press 1, I want the display to be 1. Now, why is that not running? I'll show you in a second. But in order to implement this and run this like incrementally in one solution, I can't use the same API with different versions. So I had to like create something that will work for that. And that is why I created this. So this is the same thing, only I've added a given here, which given I am using calculator v1, and when you see v1, that means it is going to be mapped to version 1 of our APIs. We do the same, and we'll see what it includes. So you see, you don't have ignore here, and this works. How does this work? Okay, so let's go through the stages. So first, I have these. This is the feature file, and the feature file is mapped to a step definition. Now, unless you see v2 here, everything is going to be repeated for v1 and always. And you see that I have given, when, then, or the other way around. And these are mapped by Cucumber to the feature file. So when the feature file says, given I am user calculator v1, what it actually says, it's translated to given, where is it? Given here, I'm using calculator v1. It sends the version as a string, and then I can use that. And I usually keep the step definition file very lean, doesn't do much, just send thing into an object which I created calculator steps, which actually does the operation. What do we have here? We have the set version, which kind of pastes together the real API. You see that the base URL is the local host, and we'll have v1, v2, and so on. Reset calculator calls a post, which you see that you don't see, but I'm using here supertest. Supertest is a test framework in JavaScript to run API, to call APIs. Now, why not just use regular request? I want to really be able to fail tests or steps if something doesn't work. So in order to do that, I need some way to tell the system, hey, something went wrong here. How do I do this? Well, if I run with a super test or any other test framework, what will happen is that, for example, here in reset, I'm going to call the reset API, and I'm going to expect a status code of 200. If it doesn't, what will happen is it just will throw an exception, and Cucumber will catch it and fail the spec. So I'm using steps as really tests, very small tests, so partial tests. I have reset calculator, which calls the reset and expect 200. I have check display, which gets a string. This, remember, in our feature file, these are sent as parameters into the step definition, so we can use them. So check display calls the display with a get API, expects 200, and expects a small JSON object with the display and the value that I expect, compares them, and if they're not the same, it's going to be an error, and it's going to fail my step. Also true for press, press key, which sends a post to /press, sends a header with content type JSON, and sends a body of a small object with key that equals what I sent here, and expect 200. So if any of this failed, my spec will fail. And this is what I want. So this is on the test or spec side. What happens on the product side? So we have on Nest, you sort of declare a controller, which kind of receives the requests. So this is our version 1 controller, and this will probably repeat as is because there's not much changes in that. There's no changes in that with the different versions. The APIs, like I said, stay the same. And what it does is basically stuff send the information into the calculator service object, which does this stuff. Okay, so here it's just passes the key in, and here it gets the display and returns it. So the controller doesn't change much. The calculator is just this. It gets the display, and on press, it just checks that if it's 0, it replaces the display, and if it's not 0, it just adds whatever key you sent. And reset calls just set the display to 0. Now, why is that? This is something that comes from TDD world, really, test-driven development, which is a principle that says that if you need to implement stuff, which we do, implement the smallest thing that works. And currently, all we have in our life is the spec, almost. So all the spec requires right now are zeros. So we do that. But it's not the only thing that it does. So I also added a couple of tests here. So these are unit tests for the calculator service, which resets it at the beginning, and then pressing any number after reset should display the number, and pressing 0 after reset should display 0, which is kind of correlates to the spec. Now, this is where we actually start thinking about what do we need in tests, what do we need in the specs. And depending on who writes the spec, you can think about, well, what do I need to do here? And we'll talk about that at the end, but currently we have in our story a non-technical person who writes the specs and a couple of examples, but it doesn't always cover everything because we expect the developers to do more covered version of what the spec. So think about it, the spec needs to be, these are examples of what needs to work, but we expect the development to, well, I've covered everything, and I proved that by having tests. So it's not going to be like one-to-one. If it was one-to-one, we probably won't need it, except for something else. Excellent. So we have that. I also have something which not that useful, but sometimes it is. It's a controller test, which is a unit test for the controller of nests. Interesting thing, which you can check that the API is returned 0, but not like calling directly the API, but running it in service. So it's an interesting way. One day we'll talk about different ways to extend your unit test. This is like a unit test for API. It's nice, but for our story, it doesn't add too much. Okay, so let's get back to our story. And our story was here. So we had this. And these were working, and the PM said, excellent, let's give you more work. So instead of just copying this and pasting and copying this and pasting for each example, nobody will do that. And Cucumber and most BDD frameworks have something like this, which is what we call data-driven tests or specs in our case. So in Cucumber, it's called the scenario outline, where you use the same things that we had until now, only put them in the sort of table, and each of this runs as a separate test. And as you can see, everything is working, and I'm reusing the same press and the same get display, which of course should work, which is excellent because this is how we like it. And the PM liked it so much, so he went on to write this. So this is what he wrote last, and he used the same thing to wrote more things. Only this is kind of a weird issue here, because this works, but it's not works as intended. Why is that? Well, this, remember, press key sends everything I give it. So it doesn't do press 7, press 8. It sends press 78. Now, press 78 is not something that the product wants or designed or thinking, but fortunately or unfortunately, it does work because the implementation works like that, which is weird. But this is like, when you look into it, what we have is a problem in the implementation of the test, not the code. So sort of had a small problem here. And this problem is mostly a misunderstanding, and this will happen between product people and developers. So what we need to do is refactor, really, or tweak the spec and the glue code. We don't touch the product because the product's still working. So what do? We have version 2. So I misunderstood the PM. PM wants to write this feature easily with tables, but it didn't mean send everything here. So let's allow a sequence to be sent, but only one key at a time. So the product will continue to write the way they want, but in order to do that and separate the press from something else, I will add press sequence. So instead of I press a key, I press a sequence. How does it look like in the steps? So I needed to add this thing here. So instead of I press something, I have a I press sequence. So it's not instead of, really, it's in addition to, because I'm going to continue running this stuff from before. And this one has a press sequence method, which looks like this was my press sequence. Yeah. So it loops over everything in the sequence and call press key for each one, which calls a post API for each one. So the test has changed. It still works because the implementation is kind of dumb, but it works. And what we actually did was translate the meaning of what the PM meant, what the business meant, and the product doesn't have to change because we didn't see any need for it until, well, not yet, because tests are still passing. So this is a refactoring of the test or the spec side. Also in V2, what did I do? Let's see what we have here. So this was this thing, and this worked, obviously, but we need to do something more, because once the business person, the PM, our excellent PM, found out that it is possible to send multiple character to press, because that still worked, he said, okay, no. This as a sequence should work, but if I send a press, a full sequence, like 12 here, I want the display to be an error. So this is like a requirement. This is not covered by all the things, but in order for this to work, I need to add a bit of code. What is this code? So in our, these are the tests. Let me show you the code first. So there's this thing that checks the length of what is being sent, and if so, the result changes to 0. And I added a couple of unit tests for that as well, because I don't trust myself and I have to do this. So I added this, so like pressing a sequence which is not of length 1 results in an error. So if I send nothing, get an error. If I send a sequence, I get an error. Unit tests work, code works, spec works. Everything's very, very, very groovy. Excellent. So we did that, and at this point the PM said, "Oh, well, I'm lazy. I don't want to write," and I reset the calculator for every single thing that every single examples that I do. So and that makes sense. Like, can't you do anything about this? And the answer is yes, I can if I can. And sort of like I'm trying to like implement known knowledge for everyone. So how do I do that? One trick that I did was to go into the step definition. Again, I'm refactoring the step definition, and for that I'm adding this here, which I didn't have before. I didn't need to before. So I reset every time I set the version. Now, you know, and I know that set version is kind of a cheat, because I need to tell you whatever version of API. In your case, it will not be that, and maybe you will need something explicit, but there are ways to do this. And again, it's on the spec or the test side, and you can play with that as well. So that works. So instead of that, we have things without reset. which is excellent. And then we move on to something else. What does the PM want now? Okay, so the PM looked at the validation that I did for the length of the key. And he said, wow, we need to check a bit more than that. What is this a bit more? I'll give you examples. And this is what business needs to do, right? And give me examples of all the things that need to fail. Okay, in business spec, that means that whenever I send a sequence like that, if it contains a character or a symbol or stuff like that, the display should be an error. Now, this is a problem. Why is that a problem? Well, it's not a big problem, but it is a small problem. I know how the code looks because I designed it. It looks like this, right? And I know that if I start adding, I can do whatever I did until now, which is I can add another if and another if and another if. But the code already starts looking like an if Frankenstein. We don't like that. So at this point, and what we usually do in development says, okay, I want to make changes here, but instead of making changes like directly and then refactoring, let's try to do something the other way around. I'm going to start refactoring, prepare a place for all the extra validation that I'm going to do, and then add the code. So if you, again, going back to principles of TDD, is that don't make changes of refactoring and new code or new requirements together, separate the two. So what we're going to do is take a step back. We know that this request now, see it's with ignore, if I run it, it will fail because I don't have implementation for that in version 2. But I don't want, what I'm going to do is going to do a bit of refactoring on the product side. I'm going to create a validator class and put, this will be where I'm going to put all the validations. But in order to do this, I need to first collect all the things that do work and run them. Again, this is like very manual thing that I did here, but you won't do because you will work incrementally on the same thing. But I kind of pushed aside the thing that doesn't work, and I'm not going to run it because I'm concentrating on the things that do work, and I'm going to do a bit of refactoring. What is this refactoring? So this is everything that we did until now in terms of specs. And what I did is basically in our validator code, put that if something doesn't validate, it will return an error. And the validator class in the current version only checks this. I just put the condition inside it. And the same specs that worked until now work now. Excellent. I did need, because I changed the code a bit, I have validator. Let's write tests for that as well. So in V3, I have also validator tests. I won't show you the calculator test, but basically these are the same one that were translated from the calculator to the validator. And now that I have that, and these things, remember, they are running and working, now I can add the one that is still not passing and pass that. How does it look like? So remember, we have a sequence with the symbols, and these are examples that we're going to run. Let's see how they are implemented. So this is V4 already. So V4 looks like this. Ignore this for a second. I'll come back to this in a minute. But if the validate doesn't work, it will display error and return just as before. But now I extended the validator to not just check the length, but also is it a key and the symbols and stuff like that. And there's valid symbols, and we want to just add digits. And one more thing that I was thinking about was that you see this C? How do you get from error? Because this is something that as I was developing was, how does this work? So let's look at the calculator again. So the calculator has like, if you press C, that means that you can get out of jail. You don't need to show error anymore, and it goes back to 0. And to prove that, I created both tests, like causing an error and pressing C resets the display, and V4 has tests as well with sequence containing a symbol, which are the approved symbols, and the non-improved symbols, and same for characters that I want to make sure that work. So these work, and then going back to these examples, they do work. And finally, PM tells me something more that will add this here, drop table from users. You don't want that as well. And this he gets for free because the code does that on its own. And what else? It took my advice of checking how do you get out of this error mode, and they decided that they're going to put that in a spec as well as an example, which makes sense because if you think about it, who is going to read these things? We're going to, if we're talking about non-technical people, they will go in and read it. The non-technical people will not look at the code. They will not look at the unit tests. So they will not know. So the product needs to manage these things in terms of what do I want to expose as specs. And if it's important enough, this could be a good candidate to put in the spec as well. So this is going like the other way around. We're starting off in a unit test because this was a development idea, and then it found its way to the specs as well through communication. And now we have everything that is working. We have tests for that. We have specs for that. Everything's cool, sort of. So what does all this mean? Well, we went through a couple of phases here. And what we saw is that I tried to play all the different participants in this play because BDD is about collaboration. And there are different ways to see and come up with different solutions to different problems. So what happened is that you actually saw, first of all, the initiation, writing everything and that it works. And then we saw increments. And then we saw refactoring on the spec code because there was some kind of miscommunication between the business and the developer. And we saw the developers adding tests because tests are important. And we'll talk about that in a second because specs may not be enough. And we also saw the refactorings. There's a new requirement that we need to do, but if we start coding with the code as is, it's going to get messy and ugly, and we don't want that. So working along with the working specs and refactoring without adding the non-passing specs gives us a true feeling of refactoring. We're not adding anything. If we're breaking something, it's because we actually broke something, and it's not like really hiding stuff. And we talked about the test and how tests can find themselves written as specs. If you watch the the previous webinar, I talked a lot about the feedback cycle, and that in specs, red specs, failing specs, can stay failing for a while. Not talking like minutes here or seconds. It could be like for days, maybe weeks, until we implement them or write the code that passes them. And that means that you don't want this red in your eye. And this is where you actually want the specs to be different than the test. This is why developers would probably want tests that are quicker to run and they are passing, and have the specs as sort of backup. They need to pass at the end, but they can't be the immediate thing that you actually saw here, because here tests like very small system, not very complex, everything's local. It makes sense that the specs would run quickly, although they already run slowly than other stuff. But this is why you need some kind of a testing layer, unit test, API test. Some of it overlaps with the specs, some of them not, but part of the collaboration and communication between the two sides is like passing information of what is important to expose, and which one, what do we want to run quickly. And at the end, you have all kinds of tests that are running, proving things are wrong. If something breaks, that are easy to debug, easier to replace. And we want that. What else did we do? Yeah, I showed you the small steps, the incremental development, and this is something that kind of people who are not familiar with TDD or BDD, developers are usually building something that is supposed to solve everything that the requirement or the spec document said. And specifically with BDD, you can work incrementally, pass this, pass this, pass this. So this increment tells you that you work this, you pass this test, you pass this spec, and you move on to the next one. And this increment is something that I wish that people were actually doing, because that means that every step until now actually worked. You have proof of that. And this is something that developers need to teach themselves, and product people as well. The working incrementally creates a better, let's say, pace of development, because you deliver things that are working. So as I was working with that, I was working inside Visual Studio and I was preparing that, and I had Cucumber, and I didn't plan on doing some TDD here. Although I'm spending time about BDD and TDD in the previous webinar. They work very well together because both come from the test first family. You write a spec, doesn't pass, you write code to pass it. TDD the same way, only with smaller cycles. But Copilot started badgering me about, do you want me to generate stuff for you? And I thought, well, let's play with that. So what I learned, first of all, it ignored the specs completely. So that means that I could generate tests from my specs, but because it didn't recognize the specs as tests, it didn't have an idea where to start. And it did what it always does. It goes to the code and generate the test that I already had. Wasn't valuable. But what I did do is kind of copied the examples and put it in the chat window of Copilot and said, okay, generate from that things. And this worked okay. It did need a tweaking because it kept suggesting things that I didn't want. The examples were not exactly what I wanted, and it did require like picking and choosing what I actually wanted. But then came the revelation. I asked it, well, you have tests, generate the code. And it regenerated the code, but the test failed. So the revelation came, well, I asked it, well, generate the code, but make sure the tests pass. And that it did. So TDD is kind of going through a change with the world of AI. And my next webinar is going to be exactly on that. Get ready for a webinar on TDD and AI. And a whole lot of AI as well, but and this is going to be the first one. So what if I asked it to do this, what happens that the cycle of TDD can really speed up things. And the most important thing is that we have the specs and the tests, because it generates the code in order to pass the tests. So I learned that it actually works. You can't leave it alone. Like, you can trust it completely. You have to keep an eye on what it's generating, if the examples that you actually want serve you, and always go back to would I write these kind of tests or examples, and because that's how we're going to leave them. So you still need to critique what it's doing and make sure that it works or not. Okay, so that was like a small piece of AI. We're going to go deeper in this in the future. So what's next? First of all, if you're interested in BDD and stuff like that, go to, and you haven't watched the previous webinar yet, go watch it. It was excellent. I was there. Get an idea of what BDD and BDT, well, first what BDD is supposed to solve and how BDD tools support this process. And I'll also talk about how people implement it, rightly, wrongly, it doesn't matter, and how it works. Today I showed you like the different steps of what actual steps we're taking and what kind of decision we need to make and what kind of questions pop up and what we need to do. And this was a very small sample that we did, and but it is like it actually happens in big and complex systems as well. If you're interested, try it. The first step I suggest people do when they first approach it is like Forget about Cucumber, forget about the tools, write examples in English, like in Gherkin or stuff like that. And write not for yourself, collaborate together with business, the developers, testers, write and configure how it would look like, because everybody needs to be in on the plan and the resolution. It's like something that we don't think about. Like the language is very simple, but today the examples that I show you is like for every step there was an API. But it could be like a step would be like 10 screens or 10 API calls. So what you need is not to specify a program for the developer. They don't need that. But start from how it looks from the outside. Write examples of scripts, and it has to be in the language of the business. Collaborate in that, experience the incremental the delivery, experiment, sorry, experience the incremental passing of test, the small steps of refactoring. Try to feel how does it look like. It doesn't have to be in the BDD world, but working with small steps, incremental steps, changes the way you work on software. It really does. So even if you're not doing TDD or BDD, try it. It's like different revelations. AI, like I said, I'm going to talk about this in the future a lot. The tools are there. Remember that the tools are not to be left unguarded. We kind of, my experience that we too quickly came to trust whatever ChatGPT says or Copilot in my experience. So you have to work in a certain process that will result in something that you can either approve or refactor and then approve. But it does change how we work, and even in things that like BDD and TDD, it's can actually speed up things, but we need to be alert about doing things. Again, stay tuned. Going to be some kind of things in the future. And that's what I wanted to share with you today. If you have any questions, put them in the box. And other than that, thank you for coming. Hope you enjoyed it and found it valuable here. If you have any question or something to that, you can use whatever you see on the screen to get here. The YouTube channel contains all the webinars that we have and the videos that I do. So watch that as well. At the blog on the site, everything is there. Thank you for coming today, and hope you have a great continuation of today. Thank you very much.